My name is Kyle Whitlow. I'm an engineer here at United Launch Alliance. We are a launch vehicle provider. We launch spacecraft.
2, 1, and liftoff. We have liftoff.
Additive manufacturing has an infinite number of applications and an extremely large potential that can be used here at ULA. We've really only touched the tip of the iceberg. This is the Fortus 900 MC. It's a fused deposition modeling machine. We use FDM primarily right now for tooling, but we are implementing it for flight hardware on a very rapid basis. We are actually fully qualifying the material through testing and getting to the point that we can qualify the process and not the part, so that we can really change how we have done business for the last 30 years. One great example is this ECS duct right here. It provides air conditioning to the hot avionics, electronics equipment on the pad. It is flight hardware, but it's just along for the ride. This is our 5-meter Atlas V vehicle. The ECS duct that you just saw actually slips around the entire circumference of our 5-meter payload fairing. It separates with our payload fairing once the booster phase of flight is complete, and there are 16 components of the additive manufactured assembly that slip around the circumference of the payload fairing. In the traditional manufacturing method, there's over 140. This makes installation and assembly significantly easier.
My name is Andrea Casillas. I'm a parts, materials, and process engineer at the United Launch Alliance. My job is I make sure that certain materials are acceptable in different applications on our launch vehicle, and also developing processes such that our parts and materials and everything are repeatable, so that every single time we have a perfect product. And we really want to use the Ultim 9085 material, and what we needed to do was ensure with Stratasys that we could have a product that was good and acceptable for certain applications, especially in the aerospace business, which has very stringent requirements. So what we did was we worked very closely with Stratasys, and they basically helped us to determine certain quality standards. And what they're doing is making sure that the product is, number one, acceptable for use, has the appropriate properties acceptable for flight application, and they're making sure that every single filament that we get, it's traceable all the way back to the raw material, which is a pellet. Additive manufacturing adds a whole different facet to the design process. What you can do is basically build really complex geometries, and we can reduce our weight, which is really important in the disposable launch vehicle business. In a lot of cases, because we do have the ability to use this high-strength thermoplastic, we're actually replacing a lot of metallic applications with plastic applications because it's substantially less expensive.
Innovations through additive manufacturing are really pushing ULA to be leaner, more cost-effective, more efficient, and enabling us to implement new innovative technologies into our design process and into our actual flight structures in a way that hasn't been done in the past.